this lesson, we will investigate the movement of water into and out of the cell. This movement occurs across the cell membrane, which is like the outer skin of the cell. This is a close-up cross-section of what a cell membrane looks like. Because the water is moving into or out of the cell, this is an example of absorption. Let's say that the top side of this picture represents the outside of the cell, and the bottom side represents the inside of the cell. These red and white molecules are water molecules. You can see that there is a higher concentration of water molecules on the outside of the cell and a lower concentration of water molecules on the inside of the cell. All molecules want to move from an area of high concentration to an area of low concentration. So in this case, the water would want to flow into the cell. In animal cells, water flowing in would cause the cells to swell up, and they could even burst. Plant cells have a cell wall that protects them from bursting, but the central vacuole would be full of water and would cause the cell to be turgid or stiff. If the conditions were reversed, and there was a high concentration of water inside the cell and a low concentration of water outside the cell, again, the water molecules would want to flow from an area of high concentration to an area of low concentration. So in this case, the water would flow out of the cell. In animal cells, water flowing out of the cells results in cells that are shriveled and shrunken up. A similar thing happens in plant cells. You can see how empty this central vacuole is. The result is that you have wilted plants. If the concentration of water molecules happen to be equal on the inside and the outside of the cell, water would continue to move in both directions equally. For every water molecule that went outside, one would come inside, and vice versa. In animal cells, this type of solution would result in water moving into and out of the cell equally. This is known as equilibrium.